In this video, we're gonna talk about the third kind of the differential equation that we have. So the third kind is gonna be the exact equation. The exact equation will be the equation of the form m xy dx plus nxy dy equal to 0. Okay, so this one is going to be exact equation if you be able to find the function uxy such that you have duxy and duxy is going to be equal to ux dx plus uy dy that we have for total differential before. Okay, so if you recall that this guy used to call total differential. So if you be able to find the function u that has total differential equal to your given function m dx plus n dy. So first of all, let's try to identify the function m and the function n. So you have the function m is going to be the function in front of dx and the function n will be the function in front of dy. So for example, you see that the thing that we have here is going to be the function n turn out to be the yellow guy and the function m turn out to be the red guy here. So you have m and n respectively. Okay, so this is how we identify m and n from example 7.1, and example 7.2 will be you see everything in front of dx and everything in front of dy. Okay, so this guy will be m and n. Okay, the next thing is going to be, we like to know whether it's going to be exact. So we're going to find a condition in order to test whether the equation turned out to be an exact equation. So we know that your m turned out to be the ux. Okay, so you have the you have du equal to m dx plus n dy. So you're gonna have m turn out to be ux, and you have n turn out to be uy. Okay, so this one here and this one here. So you have m equal to ux and n equal to uy. Okay. The way that we're gonna test whether we're gonna be able to find u come from the second order derivative. For the second order derivative, if you find the partial derivative of m with respect to y, okay, so if you compute the dy of m, so you get uxy. Okay, so this is the thing that we have learned in the partial derivative chapter. And if you have the ndx, so the ndx will be, you just differentiate with respect to x. So you have the mdy and the ndx, and it will follow that you have uxy and you have uyx. And we learn in the second order partial derivative that you always have uxy equal to uyx when you have nice function. Okay, so the nice function is going to turn out to be the continuity that we already discussed. So it's going to be the function that we be able to find derivative quite nice or quite easy. So it's going to be just the one that continuous. So you have uxy equal to uyx. So the green one will imply the condition that you have the m dy equal to the n dx. So if you have the n dy equal to the n dx, it's gonna give you the condition that your equation turned out to be an exact equation. Okay, so the conclusion that we can draw here is going to be, you'll be able to conclude that your equation is an exact equation if and only if you have the m dy equal to the n dx. Okay, so this is the thing that we gonna do. Okay, so after identifying m and n, we're gonna find dm dy and we're gonna find dn dx. So please do this one. Okay, so you have m and n that you already have, so you're gonna compute dm dy. So basically it's gonna be, you're gonna differentiate this guy with respect to y. So when you differentiate with respect to y, it's gonna be, the first term turn out to be 3x squared and the second term turn out to be 2x. So it's gonna be 3x squared plus 2x, okay? And you have dn dx. So for this guy, you're gonna differentiate with respect to x, so it's going to be 3x squared, differentiate is going to be 2x, and differentiate 2y with respect to x is going to become 0. So this guy will be 3x squared plus 2x plus 0, and this one turned out to be the same. Okay, so this guy turned out to be the same. So we gonna conclude that it is exact equation. So we have an exact equation. Okay, so if you find the derivative with respect to y is turned out to be equal to derivative with respect to x, so it's gonna be exact. Okay, so that is gonna be the conclusion that we have. Okay, let's do another one. So you have m equal to e to dx minus cos y plus sine 2x, and n equal to root y plus x sine y. So you're gonna differentiate dm dy, okay? So it's gonna be dip cos, it's gonna be negative sine, so it's gonna be negative sine y, okay? And this guy turned out to be just sine y, and you have dn dx. And for dn dx, it's gonna be, you need to differentiate only the term with x, so it's gonna be just sine y. Okay, with me so far, derivative with respect to y turned out to be 0, 0 disappear, and the thing that you need to differentiate is going to be just cosine y. For another one, it's going to be 0, and you need to differentiate x sine y, so it's going to be sine y. So this gonna give you equal. Okay, so it's going to be exact. Okay, so you have two equation, exact equation. Okay, so this one is going to be the first one, and the second one are exact equation. The next step, I'm going to teach you how to solve the exact equation. The way to solve exact equation, we need to identify the function u that will satisfy ux equal to m and uy equal to n. Okay, so we need to identify that u. Okay, so you need ux equal to m. Okay, so you need ux equal to m. So you're gonna just use m. So it's gonna be ux dx equal to m dx. Okay, and your m turned out to be up here that you're gonna copy down. Okay, so it's gonna be 3x squared y plus 2xy dx. Okay, so you basically copy the term that you have on top down. Okay, so you just copy everything, and the way that you're gonna identify u will be, you're gonna just integrate both sides. Okay, so you would just integrate this guy both sides. So this one will give you uxy. Okay, so this one will give you uxy, and you basically integrate this guy with respect to x. So you think about the double integral. So you have integrate 3x squared, so it's going to be 3y, okay, and you integrate x squared, you integrate x squared, it's going to be x cubed over 3, okay, so that is going to be the term that I'm going to put down. So it's going to be x cubed over 3 and you integrate 2xy, so you get 2y, and you would just integrate x, okay, dx, so it's going to be x squared over 2, okay, so it's going to look like this, so it's going to be x squared over 2, okay, and you're gonna have to plus constant, okay, so I'm gonna plus constant. However, you are integrating with respect to x. So the constant turn out to be the function in terms of y. Okay, constant here you are integrating with respect to x, and the constant that you see is gonna turn out to be the function in terms of y. So we're not gonna have just like a number for constant. This thing that we're gonna plus for constant turn out to be you're gonna plus gy, okay, or ky, okay, so you're gonna plus ky. This one I'm gonna say that this guy is constant in terms of y. Okay, so it's gonna be the constant in terms of y. It's not going to be constant numbers, okay? So it's going to be constant in terms of y that we need to identify next, okay? So for this one, you have uxy equal to, let me simplify. So you have your uxy, so you can get rid of 3 and 3, so you get yx to the third plus yx squared, okay, and plus ky, okay. So we need to find the function ky here. So it's going to be, you need this guy. How could we identify this guy? It's going to be, you know that, okay, so you know that we know uy must be equal to n. Okay, so you need you know that uy equal to n, and what is n? N is the yellow guy. Okay, so I will copy the yellow guy down. So it's gonna be x to the third plus x squared plus 2y. Okay, so that the yellow one that I have for n. Okay, so you have n equal to x to the third plus x squared plus 2y, that uy. And you see that from here, you're gonna be able to find uy by derivative of y. Okay, so you basically differentiate this guy with respect to y. So it's gonna be x to the third, okay, with me so far, that term. And you find derivative with respect to y. So you're gonna get just x squared. And for the final term, you need to differentiate ky with respect to y. That would get k prime y. Okay, so that is going to be uy. Okay, so you see uy, you have derivative of u with respect to y. So you get x to the third plus x squared plus k times y. So it's going to be x to the third plus x squared plus k prime y. Okay, equal to, you have x to the third plus x squared plus 2y. And this will allow you to get rid of x to the third and x squared. And this one, you have k prime y equal to 2y. So in order to find ky, will be just, in order to find ky, you basically just integrate this guy with respect to y, okay? So it's gonna become integrate with respect to y of 2y, okay? So it's gonna be y squared, so it's gonna be 2y squared over 2 and plus, now it's going to be just constant because it's one variable. So this one is going to be just normal constant, which is number. Okay, so which is a number. So you have ky equal to this one, and we're going to plug ky back into the function here. Okay, so we're gonna plug ky back into here. So you would get uxy equal to yx to the third plus yx squared plus this one is going to be y squared plus c. Okay, so that will be okay, so that will be your uxy. Okay, so this is uxy equal to ux to the third plus yx squared plus y squared and plus c. Okay, so this is going to be the way to solve this one. Let me conclude the step for doing this example. The first step will be you need to check whether you have exact equation. The second step is going to be you find uxy. Okay, so the second step is going to be around here that you find uxy. Okay, and the third step is going to be you're going to get rid of the not you find you're going to find ky by just using uy equal to n. Okay, so this one will be the third step. Okay, so this one will be the third step. And so this one is a little bit long. Okay, so we're gonna have a shorter way in order to solve this equation. The first step turned out to be the same. Okay, the first step turned out to be that you need to check for exactness of the equation. The second step turned out to be different. Okay, the second step turned out to be different. So let do another way. So for this one, it's gonna be I'm gonna copy everything down. Okay, so I'm gonna take a screenshot here. Okay, so I have the equation. I have this equation, and the way that we gonna solve this equation, let do this one. This one is number 2. So you have 2 prime. Let's say it's shorter way. Okay, so it's going to be a shorter way in order to find the function u. So the function u will be identified by you just pick one. Okay, so you know that this guy is exact. Okay, so basically uxy will be you're gonna just pick one to integrate. So let's say you pick this guy. Okay, so let's say you pick this guy. So let me move this one a little bit. So you gonna just integrate the pink one. So you integrate 3x squared y plus 2xy dx. Okay, so you just integrate this guy. So you basically integrate this one quite easy. So like I told you before, you integrate dx, right? So you integrate only x squared and you integrate only x. The rest turn out to be constant. And you get the same thing. You would get x squared y plus, not x squared y, x to the third y plus x squared y, okay? And this one come from the integration. Okay, so this one is going to be x to the third y plus x squared y. So this one I would say it's going to be the first step. This one is the first step. The second step is going to be you're gonna let's move this guy closer. This one is going to be your first step. The second step will be, okay, you're gonna find derivative with respect to the opposite variable. So what does it mean? It means that after you are integrating with respect to x, okay, so you see that it's going to be with integrate with respect to x, you're going to differentiate with the variable that opposite the x. So it's going to be you're going to differentiate with respect to y instead. If you differentiate with respect to x, it's gonna like go back to the loop. Okay, so it's gonna go back to the loop like this and you go nowhere. Basically, you go back to the beginning. Okay, so we're gonna differentiate with the opposite variable. So you would just find d dy. Okay, so you just find d dy from this guy. Okay, so you basically differentiate with the opposite variable and you have x to the third plus x squared. Okay, so you differentiate with respect to y, you get x to the third plus x squared. And so this one is the second step. This one is the second step. And so you would just have x to the third plus xy. So you get this one. And this one, you're gonna go back to n. Okay, so you differentiate, you get x to the third plus x squared, and you're gonna have see that you have x to the third plus x squared here, right? So you have x to the third plus x squared here. You're gonna cross out the term. So you would just cross out these two guys, okay? Okay, so you're gonna cross out these two guys and you're gonna add by, okay? So you're gonna add by the integration that you have left. So it's gonna be 2y dy, okay? So you see this one is gonna be the third step. Okay, so this one is gonna be the third step. So you begin this guy. So this guy, you have x cubed, okay? And you're gonna cross out, okay? So you cross out, let just move number 3 here. And number 4 turn out to be down here. Number 4. Number 4 is you copy down the term that you have left after the elimination. So you're gonna get 2y dy, okay? And then you're gonna continue the fifth step. The fifth step turned out to be you're gonna integrate, okay? So you're gonna integrate this term. So you're gonna integrate this term, so you get y squared plus c, okay? So this one will be your final answer, okay? So I'm gonna just use the same color, y squared plus c, and this one is your fifth step. Okay, okay, and then what? And then you're gonna just copy this term down. Okay, so you basically copy this term down. So this one will be your uxy. Okay, so this one will be your uxy. Okay, so you have uxy equal to the same thing as you have up there. Okay, so this one will be the thing that you have up there and they are identical. Okay, so they are identical here and this one will be your final answer. So this one is the third step prime. Okay, so that is going to be the third step prime. So you see that hey, this one seems longer. Why should you say that this guy is a shorter way? It is a shorter way because this one I explained everything quite truly. However, when in practice, you're gonna be able to do this one quite quickly, okay, as I will show you in the next example. So the thing that we will need will be this uxy, okay, that I will show you in the next example, that you'll be able to find this one quite short, okay. Let's do this one. So we have shown that this guy is an exact equation, okay. You're gonna begin the 2 prime, okay. So you're gonna begin the 2 prime. Let me just take a screenshot for this guy. So the 2 prime will be, you're gonna have uxy given by integral of e to the x minus cos y plus psi 2x dx. Okay, so you're gonna just have this one and you integrate everything with respect to x. So it's gonna be e to the x, okay, minus cos y x, okay, and you integrate psi to x is gonna be what? It's gonna be integrate psi, you get negative cos 2x over 2, okay. So this is what you have for your first step, okay. So you integrate, so this one is your first step, and you're gonna derivative with the opposite variable. So you are integrating with respect to x, so you're gonna differentiate with respect to y instead. So you differentiate with respect to y, so you dip e to the x, you get 0. You differentiate with respect to y, you get negative. Dip cos, so it's gonna be negative psi y times x, okay. And you differentiate with respect to y, you again getting 0. And you see that, hey, this guy, this is what you have here, okay. So this one is your second step, okay. So this one is your second step. Let me move this one a little bit lower. So you see that you're gonna do the cross out in the third step. So in the third step, you're gonna just cross this one out because this term is identical with the term that you have down here. Okay, so you cross this term out, and what next? So you're gonna add by the term that you have left for y, which are root y dy. So this is gonna be the term that you have left up there, okay? And then you're gonna just have this to be the fourth step, and the final or the fifth step turn out to be you gonna integrate, okay. So you're gonna integrate root y dy, so it's gonna be this one is y to the 1/2, right? So it's this guy is y to the 1/2, so it's gonna be y to the 1/2 plus 1 over 1/2 plus 1 and plus c, okay. So the rest of the term just copy down, okay. So the rest of the term, you basically copy them down. Okay, so this one will be this term, and you're gonna add them together to obtain the final answer for uxy. Okay, so that is going to be your function uxy. And the question turned out to be you have uxy equal to 0 for general solution. Okay, so it's going to be uxy equal to 0 for general solution. Okay. So for the next one, okay, so for the next one, I like to show you another thing from this example. You may ask me that, hey, can I just use this term to begin with to find uxy. So you see that I most of the time I use this guy to find uxy, right? So that the beginning of my solution. However, you may have in mind that can I just use the second one? Will we get the same solution? Of course we do. Okay, so of course we do. However, let's show you. Okay, let's also take the screenshot here. Okay, so you have this one. Okay, so you have this one, and we're gonna try to find two double prime. Let's just say that we have another way. So it's gonna be two double prime like this, okay? So we're gonna begin by just you have uxy, okay? And you just use the yellow one, okay? So you just use the yellow one, so it's gonna be root y plus x psi y dy, okay? It's a little bit messy, but we can do it, okay? So you have indicate root y, okay, indicate root y again, it's gonna be y to the 1/2 plus 1 over 1/2 plus 1. And you integrate x sine y, so you would just get x negative cos y, okay? So that is gonna be your first step, okay? So this one is gonna be your first step. And your second step will be you gonna just find derivative with respect to the opposite variable. So you would just have y here, right? So you're gonna differentiate this guy with respect to x instead. Okay, it must be opposite of the thing that you have done before in the first step. So it's gonna be what? It's gonna be 0. Okay, so it's gonna become 0, and it's gonna be derivative of cos, which is negative side. So it's gonna be just x negative sine y. Okay, and so you're gonna have, okay, so it's gonna be, sorry, you find derivative with respect to x, sorry. You find derivative with respect to x, so d dx. So this guy disappear, so this one is going to be negative cos y. Okay, and you see that for the third step, you're gonna take a look here that this one will be crossed out. Okay, so it's gonna be crossed out. And the thing that you have left will be these two terms that you would copy down. So it's going to be integrate e to the x plus psi 2x dx. Okay, so this one is your fourth step. Okay, and the fifth step turn out to be you need to integrate e to the x plus psi 2x, so it's going to be e to the x. Integrate psi is going to be negative cos 2x over 2 and plus a constant c, okay? And you will copy the rest of the term down, okay? So you copy this guy. So you copy this guy down. Okay, so that will be your uxy. Okay, so it's going to be your uxy. So you see that you get the same uxy as before, okay, when the term is a little bit different, but it's okay. So they are exactly the term, the same thing with the one that you already had before. Okay, so this one will be this guy, and the general solution will be equal to 0. Yeah. Okay. The last thing for this example, if I also give you the condition, okay, if we know that y0 equal to 1, okay, we can find c by, okay, so we can find c by, so if you know further that y0 equal to 1, so you're gonna put x equal to 0, y equal to 1 into the equation. So you're going to be able to solve for c, okay? So you have what? X equal to 0 is going to turn out y equal to 1, so it's going to be 1 over 3 half plus 0, okay? And you have e to the 0, have e to the 0, and you have cos 0 over 2 plus c equal to 0. So this one will be just 2 half. Okay, so you have c. Okay, so you would have c. C equal to what? C will be equal to negative 2/3. Okay, minus 1. Okay, and you're gonna plus 1 half. Okay, so you're gonna have negative 2/3 minus 1 plus 1 half, and this one will be, this one is going to be negative 5 over 3. 5 over 3 is 10 over 6. Okay, negative plus 3 over 6. So it's going to be negative 7 over 6. Okay, so that will be my C that can be put here, okay, for particular solution. So I gonna just make this one a little bit smaller. Okay, and then you're gonna just have uxy. Okay, so I don't need uxy anymore, so it's gonna be y to the 3 half. Okay, y to the 3 half times 2/3 minus x cos y, okay, plus e to the x minus 1 half cos 2x, okay, minus 7 over 6 equal to 0. Okay, so this one will give you the thing that called particular solution. And this would give you the particular solution when y0 equal to 1. Okay, so that would be the thing that we have for this one. So basically, you don't need to do 2 double prime. Okay, so you can just have 2 prime and you get the general solution, and if the question give you something extra, you'll be able to use it for finding the solution for C, and you're gonna get the thing that called the particular solution. Okay. Okay, for the last one, okay, so you have y, 3y, x squared minus 1 and dx, so you know automatically that this guy will be your M and this guy will be your N. Okay, so you have your M, you have your N. So you would just check the MDY. So you would just check the MDY. So you see that it's going to be 3x squared minus 1 and dn dx turn out to be 3x squared. Dipsec is 0 and you get dip 3x is going to be minus 3 and they are identical. Okay, so this one is 3x squared minus 1 and they are identical. Okay, so it is exact. So it is exact. So we gonna find, okay, so we gonna find what? We gonna find uxy, okay? So you're gonna have uxy turn out to be, you're gonna integrate your m, so it's gonna be 3y x squared plus 1 dx. So this one I just copied out from the question. Okay, so you just integrate. So you're gonna integrate with respect to x. Okay, so you would just get 3y and you integrate, so you get x squared. So it's going to be x to the third over 3, x to the third over 3 plus x dx. Okay, so you just have each term like this. So this one is just the first step. Okay, so I ask you to do or to continue this example. Okay, so I ask you to continue this example until you get uxy equal to something plus c equal to 0. Okay, so this is the thing that you need to do on your own first, and I'm gonna give you the solution during the recitation. And I'm gonna just, if we know that y0 equal to pi over 4. Okay, so if we know that y0 equal to pi over 4 phi c. So you're gonna be able to obtain the solution. So you continue now, step 2, step 3, step 4 until step 5. You're gonna get uxy equal to something plus c equal to 0. And you're gonna be able to find the particular solution when you have y0 equal to pi over 4 as well. Okay, so I'm gonna just leave you to do this one and I'm gonna get back with the solution during the recitation. Okay, so that should be all for this clip. Okay, this one is called the exact equation. The thing that you need to do is going to be you check for exactness and so for uxy equal to 0. Okay, so that's all.